Welcome to Maths and Science by IITian channel. In this lecture, we will be discussing about the functions and relations or relations and functions. Either way you can call them. We have already introduced ourselves to definitions of a function and definition of a relation and how to identify functions from the given relations. Now, we will extend our study to different types of relations which are reflexive relations, symmetric relations and transitive relations. We will go and define these and identify them with an example. The example which we have taken, A is equal to 3, 5 and B is equal to 7, 8. In the previous lectures, we will be continuing with that only. Let us say A is equal to 3, 5 and also B is equal to 3, 5. In this particular lecture, we will take this. Now, we will define the Cartesian product. We will find out the Cartesian product and number of elements of A. Here number of elements of A is equal to 2. Number of elements of B is equal to 2. Number of functions is equal to Q to the power of P, that is 2 to the power of 2. Number of functions is equal to 4. Number of subsets is equal to two to the power of PQ. Number of subsets, that is equal to number of relations, that is equal to 2 to the power of PQ, that is 2 to the power of 2 into 2, that is equal to 2 to the power of 4, that is equal to 16. These are the number of relations. Number of functions is Q to the power of P, that is 2 to the power of 2, that is equal to 4. Now, we know how to write the number of relations and how to identify number of functions. The functions, various functions are there. And out of these 16 relations, in this lecture, let us try to identify reflexive relations, symmetric relations and transitive relations. How many are there? That is our target now. The target of this lecture is to find out the reflexive relations, symmetric relations and transitive relations when A and B are given with certain number of or certain cardinality of both of them. We can develop A cross B, that is Cartesian product of A into B, and we can develop the subsets of relations, and from that we can identify the functions, and afterwards, till this time we have done those activities already in the previous lectures. Please see the previous lectures on functions and relations for understanding better. Now in this lecture we will be talking about reflexive relation, what it is, symmetric relation, what it is, and what is transitive relation. and how to identify them and how many are there in this particular Cartesian product of 16 relations. There are 16 possible relations. How many reflexive relations are present here? How many symmetric relations are present here? How many transitive relations are present here? In this 16 relations. This is our target. Let's move further. It's a very important topic. Please pay attention. It is very much required to understand the basics and concepts very clearly to answer the questions in JEE Mains, JEE Advanced and CSIR Mathematics and higher mathematical examinations. Please try to pay attention. Please do not skip this video. See till the end, and at the end we will be defining equivalence relation. What it is? Equivalence relation. Now, let's go for solving this problem. Many questions are asked on this concept in many various examinations, and it is better to understand the concepts for improving your mathematics as a mathematics enthusiast. Now, question is, find reflexive, symmetric and transitive relations when A is mapped to B, where A is equal to set of two elements 3, 5 and B is equal to set of two elements 3, 5. I have taken, when you are learning, start learning with simple things and step forward for complex things. Now we have taken a set of two elements in A and two elements in B, and the elements are same in both the sets. Now, let's go for solution. First of all, let us try to analyze. When the relation A to B is established or mapping A to B is established, number of relations, number of subsets of A cross B is equal to 2 to the power of PQ, that is equal to 2 to the power of 2 into 2, that is equal to 2 to the power of 4, that is equal to 16. Number of subsets is nothing but number of relations. Number of relations. Out of them, all the relations are not functions. Number of functions out of these 16 is q to the power of p, that is 2 to the power of 2, that is equal to 4. That means there are 12 relations which are not functions. It implies there are 12 relations of A cross B which are not functions. These are all basics we have done in the previous. lectures. Now, what are those relations? 16 relations let us try to write. Because it may look little bit of exercise, but it is always better to do. What are the list of relations? 16 relations. A to B, where A is equal to 3, 5, set of 3 and 5, 2 elements, and B is set of 2 elements, 3, 5. In the previous lecture, we have taken both the sets, disjoint sets. A is 3, 5 and B is 7, 8. We will go to that level also. Slowly we will move. Here we have taken both the sets are same, 3 and 5. Now, how the relations are defined here? The first relation is empty set. Empty set is the subset of, because all subsets, these are relations, either you call them relations or you call them subsets. Subsets of A cross B. First relation is, or first subset is empty set. Second subset first element 3 to 3, mapping from 3 to 3. Third subset will be mapping from 3 to 5. Subset, and it is a relation. And fourth one is 5 to 5. We can say 5 to 3 because we will go in an order. Let it not be observed. Fifth, so that you will remember the process. 5, 5. Sixth, 3, 3 and 3, 5. 3, 3 and 3, 5. Seventh one, 3, 3 and 5, 5. You just see, we are going in a systematic way. Eighth one will be 3, 5 and 5, 3. And ninth one, 3, 5, 5, 5. These are all subsets of A cross B. 10th subset is 5, 3, 5, 5. 11th one will be Here we have forgotten 3, 3 and 5, 3. That let us write. We have missed out, we will write. Now, 12th will be 3, 3, 3, 5, 5, 3. 3, 3, 3, 5, 5, 3. You just see, in the first, we put these two together. This is the sixth subset. In the seventh, what we have done? We have put this and this together. This and this and this and this. You see, 3, 3, 5, 3, 3, 3, 3, 5 and 3, 3, 5, 5. Next we started with 3, 5, 3, 5, 5, 3, 3, 5, 5, 5. Because we have already completed 3, 3, we have not touched again 3, 3. Next started with 3, 5. Next started with 5, 3. Because we have already completed combinations of 3, 3 and 3, 5, we have not touched them. With 5, 3, only 1 is there. 5, 3, only 1 is there. This one. Now, we have to have subsets of 3. That means 1, 2, 3. 3, 3, 3, 5, 5, 3. That is one subset. Another subset will be, please try to understand carefully. We'll keep these two same, and from 5, 3 we'll move to 5, 5. Because that is left over. You have to use everything, all combinations. 3, 3. Now, 3, 3, 3, 5 we have used all the combinations. Now, 3, 3, 5, 3 we will use that combination, and it will become this. It may be tedious, please try to understand how we are developing this. And once 3, 3 is over, now we will move with 3, 5, 5, 3, 5, 5. You ensure that all these are utilized fully. Now, last and final 16th one is 3, 3, 3, 5, 5, 3, 5, 5. Three, 3, 3, 5, 5, 3 and 5, 5. Now we have got because we have misplaced this one, we will put it back here. What we will do? This will be 3, 3, this one, and 5, 3. And we will make it as 3, 5, 5, 3 here. Here we will make it as 3, 3, 5, 3, 3, 3, 3, 5, 3, 3, 5, 3. Here it should be 3, 3, 5, 3. we will make it little bit, because we should not deviate from the 3335, 3353, 3355. Next, 3553, correct? 3555, correct? 5355. Five three five five. Now the order is perfect. We have put it in the. To make this order, please practice. Now we have 16 relations. Let's remove all this so that for further understanding there should not be any confusion. I am removing all this. Only for understanding purpose I have written this. It's not required, because this list is very much required now. From this list, I have to find out. I don't know anything. This list I have made. How many are the functions and what are they, and how many are the reflexive relations, and how many are the symmetric relations. They have this symmetric relation with them, and how many have transitive relation between them. Now we'll try to understand. This is the vital part of the total lecture. Now, let us try to find out functions. Then afterwards, I will be defining what is symmetric relation, what is reflexive relation, and what is transitive relation, and we will identify them in the given 16. What is a function? In a function, all the elements of in the relation, which can be called as a function, if all the elements in A are mapped to some one in B, there is no element which can have two outputs. One input, all the elements in A should have an output, and each input can have only one output. Now, you please think, in 5 what it is happening? There is no input defined, because A is 3 and 5. 3 and 5 are not defined. In 3, 3, 5 is not defined. Just see, in 3, 5, there is a relation between 3 and 5, but there is no relation between 5 and 3. In 5, 3, there is a relation between 5 and 3, but there is no relation between 3 and some element in B. In 5, 5, there is no relation for 3. That means each and every element, in A is an input. Let us take it in practical sense. All elements should be defined for a relation in A, and these should have output in B. For example, 5, no element is defined. In 3, 3, the relation is there between 3 and 3, but for 5, there is no relation. For 3 to 5, the relation is there, but for 5, there is no relation. Element 5, the first element is of A and second element is of B. All the elements of A are not defined here. Only 3 is defined here, only 5 is defined here, only 5 is defined here. Here, only 3 is defined in A. And also, 5 is not defined. At the same time, 3 has 2 outputs. It should have, there should be, this is the first condition. Second condition is, there should be only one output for an input from A. There should be only one output. Here for 3, 2 outputs are there. And here 3 and 5 are defined. 3 has got an output of 3 and 5 has got an output of 3. There is no problem. That means 7, the relation 7, relation R7 is equal to a function. Please try to understand. That is, relation 7 is 3, 3, 5, 3. Here, element of A 3 is also defined relation, and element another 5 is also defined, because A is containing 2 elements. Both the elements, they have got outputs. They don't, a single input does not have a multiple output, and at the same time all the elements are having an output. The output can be same, there is no problem. R7 is a function. Now, let us talk about R8. R8, what it is? 3, 3 and 5, 5. Please try to understand this carefully. From A, 3 is defined. From A, 5 is defined. Both the elements are defined. Both the elements have a relation and get a output here. Different outputs. No problem. This implies 3 to 3. One relation, 3 to 5 to 5 is another relation. That means both are defined. Here 3 to 5 is one relation, and 3 to 3 is one relation, and 5 to 3 is another relation. Both are defined. It's a function. Now, let us talk about R9. Please try to understand it. Follow me carefully. 3, 5. R9 is 3, 5 and 5, 3. This may look simple, but be very, very careful while handling these functions and relations. This is the heart of these functions and relations. Understanding the definitions and identifying them and finding the number of functions, number of relations, symmetric, transitive and reflexive. Now, these relations are 3 to 5, first relation. Next is 5 to 3. That means both 3 and 5 are having relation, both the inputs, and they have got outputs also. Hence, it is a function. Now, R10, let us write with same pen, same color pen. R10, 3, 5, 5, 5. 3, 5, 5, 5. What it means? 3 has got a relation with 5. 5 has got a relation with 5. That means 3 and 5 both have some output in B. The output can be same, no problem. But a single element in A should not have two outputs. This is also a function. Now, let us go for R11. What is R11? 5, 3, 5, 5. That implies 5 has relation with 3 and 5 has relation with 5. First of all, only one element is having a output. Other element 3 is not defined here for an output. It is not associated with an output. Hence, it is not a function. And second thing also, the only number which is associated with an output is 5 having two outputs, 3 and 5. Hence, it is failing on both the fronts. Hence, not a function. If you see other combinations except for R7, R8, R9 and R10, except R7, R8, R9 and R10, all other relations are not functions. Cross check, that is your homework. Treat it as a homework and cross check. Hence, number of functions is equal to 4, that is 2 to the power of 2, that is equal to q to the power of p. And all those 4 functions are defined and we have identified. Now next comes the question. Relations are 16, functions are 4. Relations are 16, functions are 4. Now, we will define one relation, a special relations here, we will define a one relation, reflexive relation in this lecture. If we talk about all types of relations, it will be a very lengthy lecture. Hence, we will define reflexive relation in this lecture and we will define symmetric and transitive relations in the following lectures. Reflexive relation. I am spending much of time on this, listing the relations, finding the relations, identifying the functions, because it's very, very important. Questions are being asked on this. Please try to understand me. Be very careful in understanding this. This is very simple logic to understand, and I am explaining in detail. Please try to understand one by one. If it takes little more time also, no problem. See the video if you want repeatedly, and see my previous videos also on functions and relations, which are about some 3-4 videos are released for further clarification. Let's not be fast here. Let us be slow and understand the concepts clearly. What is a reflexive relation? A relation is called a reflexive relation is called a reflexive relation if AA belonging to relation, because we have defined 16 relations here, please try to understand. An element A and another element A belonging to R for every A belonging to A. This is the technical meaning of reflexive relation. Why something is reflexive and why something is not reflexive? What is A here? Just to try to understand first. What is A here? A is equal to set of 3 and 5. And what are the elements? 3 belongs to A and 5 belongs to A. That means for every A belongs to A, the relation should be AA. Are you able to follow me? Please follow this. Understand me carefully. 3 belongs to A and 5 belongs to A. For every AA belongs to the relation. Here A means don't think that only one element. Here 2 elements are there. Then what are the combinations of AA? AA can be here A is equal to 3 or 5. A is not a single number. 3 belongs to A and 5 also belongs to the set A. 3 or 3 and you can say. AA means AA belongs to R. If 3 belongs to A is taken, For every, you please try to understand. That means for every element in A, there should be relation. And that relation should be such that that relation should be such that this way. A need not be only one element. A can be many number of elements. Please try to understand this. Here, let me take a subset 3, 3, 5, 5. That means every A belongs to A implies A is equal to 3 and A is equal to 5. Do you agree? This is equal to not 3 or 5, it is 3 and 5. That means the relation should define for both A is equal to 3 and A is equal to 5 also. Here, if you see, what is the meaning of reflection? A to A is reflection of A on A. Three to 3 is reflexive. 5 to 5 is reflexive. For every A, what should be the relation? What are the A's here? A's in A are 3 and 5. For every A, please see, it is every A belonging to A. The reflection should be AA. It should be AA. Please see this. That should belong to relation. That means for every A, 3 and 5, 3, 3 and 5, 5. That is AA. Should belong to relation R. Now, you see how many relations are there such that, how many subsets are there such that the subset contains 3, 3 and also 5, 5. Not only 5, 5 and 3, 3 individually. Both should be present because for every A we are talking here. Here 3, 3, 5, 5 it is for R8 and 3, 3, 5, 5. 3, 3 is there, 5, 5 is there. This is R13. 3, 3 is there, 5, 5 is there, R14. 3, 3 is there, 5, 5 is there for R16. That means, what are the relations which have both 3, 3 and 5, 5? For reflexive relations, for every A belongs to A, AA should belong to R. Now here we have to find for 3 and 5 in A, because 3, 5 belong to A. A is a set of element 3 and element 5. 3, 3, 5, 5 should belong to R. This is the condition. It never said that only 3, 3 and 5, 5 should belong. It has said they should belong. It's not only belong. That means R can have other subset elements other than AA also. It should be understood well, because it's not, the definition never says that it should only contain this. It should contain this. For example, if you should have 5 rupees for buying a bus ticket means, if you are having 100 rupees means, or 5 rupees, 10 times of 5 rupees, that 50 rupees means, it does not exclude having more than what is minimum required. If you have to pass an examination with 35% marks, it doesn't mean that by getting 75% marks you will fail. Hence, AA should belong to R. It doesn't mean that other elements should not be there in R in the form of subsets. Hence, all the subsets which have 3, 3 and 5, 5 are the relations, reflexive relations. Hence, what are the reflexive relations? In addition to R8, R8, R13, R14 and R16. Hence, reflexive relations are 3, 3, 5, 5 and this is R8, and what more? R13, 3, 3, 3, 5, 5, 5. 3, 3, 3, 5, 5, 5 and R14, 3, 3, 5, 3, 5, 5. 3, 3, 5, 3, 5, 5. This is R8, this is R13, this is R14. And another one is R16, 3, 3, 3, 5, 5, 3, 5, 5. Another one is 3, 3, 3, 5, 5, 3, 5, 5. This is R16. That means R8, R13, R14 and R16. Hence, reflexive relations are R8, R13, R14 and R16. They are 4 in number. This is how the number of reflective relations for the given set of elements when two sets are given is found out. And I wish to give one homework to you. Please take it seriously and do it. On the same lines, find reflective relations in the Cartesian product of A cross B if A is equal to 3, 5 and B is equal to 7, 8. Relation is from A to B. A is 3, 5 and B is 7, 8. When A is equal to 3, 5 and B is equal to 3, 5, I have done it. When A is equal to 3, 5 and B is equal to 7, 8, try to do it. I will solve this problem in the next class, next lecture. Please comment your answer in the comment column. By finding your answer. It is about finding the reflective relations, reflexive relations, and other relations are symmetric and transitive relations. About these relations, we will be learning in the subsequent classes. Please try to solve this problem for reflexive relations. Then we will take up symmetric relations. With this, I want to conclude this lecture. It might have gone to a length of about 1 hour, but still it requires this much amount of discussion to understand better. So that if you see this video repeatedly and understand the concepts, once your concepts are clear, there will be minimum chances of making an error in the examination. Best of luck to everybody. Thank you for seeing my lecture. Thank you for listening to me. This functions and relations is a very, very important topic and it's a backbone for the mathematics. And we will be moving forward to other mathematics parts. Once you understand clearly about functions and relations, we will move to calculus, trigonometric functions, other parts of the mathematics. Best of luck to everybody. Thank you for listening to me. If you feel there is a value addition because of this lecture to you, kindly hype this video, share this video and subscribe to my channel Maths and Science by IITian. Now, after completing this symmetric and transitive relations also, we will go into the numerical part of this section, functions and relations. We try to solve some problems of CBSE level, of class 11 and class 12, and also some JEE mains and advanced level problems. Thank you for seeing and listening to me. Best of luck.